Hey guys, this is the teaching video starting a new chapter on the sun, earth, and moon. Um, so we're just gonna go straight into this next chapter. So the first lesson will be on a couple different things, or well, probably several different things, but some of this you probably remember from earlier grades, but some of these might be new words, but today we're going to explain the role of gravity and inertia. Going to define revolution and rotation, and then finally explain why seasons change. All right, and then to do this, I just came up with a few questions, and I'm going to just go through each one of these questions and just kind of answer them, and all I want you to do is just listen. All right, so I'm just going to go through these questions. I'm going to just go through them one by one. All right, the first one, the one in orange. Why does the Earth have night and day? Right? So if you think about it, you go to sleep at nighttime and we are awake during the daytime, and during the day we go to work, go to school, we do a bunch of different things. But why is that? Why do we have sunlight during the day and why don't we have it at all at nighttime? Right? So a couple of different things. For those of you who remember, the Earth is always spinning, right? It's always spinning. And if you remember, the Earth spins on or rotates on its axis. Axis is just kind of like it's kind of like a line that goes through the Earth, and it kind of like in the Earth is always tilting, and it just always spins on its axis, or it rotates on its axis. So the Earth can spin like this, just like that, spins on its axis. And it also spins or rotates around the sun, just like this. And of course, if you remember about the Earth, it does both of those things at the same time. It spins on its axis, and it spins around the sun. So the Earth is doing this all the time. It never ever stops doing this. It's constantly rotating or spinning. And if you notice, what is it? It's also spinning around what's called an orbit. What is an orbit? An orbit is just it's the path that the Earth takes when it's moving. So how could you describe Earth's orbit? You could define it as Earth is orbiting the sun. It's constantly going around the sun. But I'm sure all of you know that. So when it rotates, it rotates 24 hours to make a day, and it goes one revolution, which takes 365 days to make 1 year. So one rotation equals 1 day, or 24 hours, which is just this, spinning like this. And of course, one revolution is just going around the sun. It starts the revolution at one point, and once it spins and comes all the way back to that same point, that is a revolution. And to get from this point and to come all the way around again, that takes 365 days or 1 year. All right. So going back to that question, why does the Earth have night and day? Okay. So just as a review, let's say this is Earth, and I know it's not the exact size, but I just did this to kind of prove a point. This is, let's say this little orange dot, let's say that's you, or that's a Bowling Green, Kentucky. So we can say that Earth gets sunlight because the sun is shining its light directly onto that point on Earth. So if there's sunshine shining directly right here, it's daytime right here. Okay? Now let's say the Earth, remember how the Earth is spinning? Say the Earth is spinning. And let's say at this point, and now you're right here. Would you be considered to be in daytime or in nighttime? You'd be considered in nighttime. Well, why is that? Because when the Earth spins, it causes you to spin away from the sun, or to spin away from the sunshine. So if you're right here, the sunshine is not getting to you. And that's why if you're right here, you would be in nighttime. We have day and night because of Earth's rotation, or because of Earth's spinning on its axis. When the Earth is spinning and it's right here, you're in sunshine, or you're in daytime. When the Earth spins and you end up right here, it's nighttime. Daytime, you're facing the sun. Nighttime, you spun away from the sun. Now you're in nighttime. All right. Second question. If it's daytime in Bowling Green, is it daytime in Russia? Okay. Well, let's say you're right here, and Russia is on the other side of the Earth. Would Russia be in daytime or would it be in nighttime? If you thought nighttime, you would be correct, because if Russia's over here, they're not getting any sunshine. They're on the other side of the Earth because the Earth has spun them away from the sun. All right. Next question. Why does the Earth orbit around the sun? All right. This is where these terms gravity and inertia come into play. Right? So when you think of gravity, you probably think of the reason why objects fall to the ground. Okay? So for example, let's say I have this quarter. Right? If I let go of it, what do you think is going to happen? It's going to fall to the ground every time. Gravity is pulling or is forcing this object to the ground. So when I let go of it, it falls to the ground. And I can do this 1,000 times. It's going to fall to the ground every time. Okay? It never stops. So gravity is the force that causes objects to attract other objects, and that depends on its mass. Okay. So in terms of the Earth, when we have the sun is a huge, massive star. It gives out all this sunlight, it provides warmth, and it's also really, really, really big. I think this may not be correct, I'm not sure, but I think it's like 30 times, well, no, I can't remember how many times bigger it is exactly than the Earth, but it's a bunch times bigger than the Earth. That just means that the sun is very, very massive. It's made up of a lot of stuff, a lot more stuff than Earth. And because it's so big, it has its gravity. It has gravity, and the strength of the sun's gravity is a lot stronger. And so the sun is actually pulling on the Earth. The Earth has become attracted to the sun, and the sun is wanting to pull it. The sun is wanting to pull the Earth towards the sun. And that's all because of gravity. Gravity, it forces objects to attract other objects. But anyway, yeah, gravity is just the gravity from the sun is attracting the Earth towards the sun. Well, you might wonder, well, how come the Earth doesn't exactly fall into the sun? Why doesn't the sun just pull on the Earth and the Earth would just go into the sun and we'd all burn up. Why doesn't that happen? Well, it's because the direction the Earth is going, it's not exactly coming into the Earth like this, because otherwise we'd all burn up. The Earth is constantly kind of going at a curve. And the gravity of the sun is always kind of pulling, or is always kind of forcing the Earth to go in a curve like this. So it's not exactly pulling it forwards, it's really just pulling it around in a curve. And the sun's gravity is doing that. Also, it's going around in an orbit because of this thing called inertia. Inertia is just the tendency of an object to stay at rest or to stay in motion until an outside force acts on it. Okay? So the Earth, it's constantly in motion, it's constantly spinning, it's constantly in a revolution, or constantly going around the sun, or revolving around the sun. And it's always moving, but unless something hits the Earth is never going to stop. So let me kind of explain that a little bit more simply. Let's say you have a quarter right here. Well, if I just leave it there, it's just going to stay there. It's going to stay at rest. Well, how am I going to move it? Well, I'm just going to have to force it. I'm going to have to use force and act on it and just push it. And it stops because gravity pushes down on it. Gravity is forcing it to stop. And also friction, but I don't know if you guys have talked about that yet. But yeah, that's what inertia is. An object is going to stay there unless I force it. And an object is going to stay, if it moves, it's going to stay moving unless something else stops it. And in this case, the quarter stops because of gravity and because of friction. But an Earth, it orbits around the sun because the sun's gravity is keeping it in motion, but also because there's nothing else really stopping the Earth from moving. There's no asteroids coming into it. There's no like superhuman giant that's has his hand ready to stop the Earth. The Earth is just going to keep moving because of inertia. There's nothing stopping it. All right, I'm going to stop the video. I'll pick it up with another one.